Hello, my name is Ozella Brundidge, and I'm a PhD student at Walden University, and this is a continuation of the project that I began in part 1. Now, the name of the project is Language Acquisition from a Neurological Perspective, and part 2 is Perceptual Development of Pre-Literacy Skills. Now, I thought we can start out with a very important concept. Before we began to teach children pre-literacy skills, we need to understand that a child's auditory coding of the phonemes and the linguistic dialect of the mother's culture may affect a child's ability to hear, sound out, and spell words from the dominant culture in the speech and the written language. Now, sensory motor intelligence is a concept that Piaget came up with back in the 50s, and we're going to look at auditory perception and processing. Now, infants are born with the ability to utter hundreds of sounds, and these are infants from all over the world. And then from the English language contains approximately 43 phonemes. And these phonemes, if the child doesn't use the cultural's phonemes, they are purged. Okay? The only information that the child needs will stay in the child's auditory center. Okay? And can be processed. Now, a child's auditory center contains what we call self-organizing networks. And as the child's networks begin to be developed, the child can hear these various letters and names and also numbers. And so we want to look at the organizing areas, or the auditory center, the location of the auditory center. Now, I believe that I mentioned in part 1 that the auditory center is along the superior temporal gyrus, okay, and it's made up of 2 distinct areas. So we're starting here at the anterior part of the gyrus, and as we move forward, we run into the Hestrel's gyrus. And basically, this is an area that the scientists found where the auditory word form begins. Okay? Now, what do I mean is the child's ability to hear and decipher sounds of the words and the phonemes. Okay? So this is done in this location of the auditory center, and it continues on what they call it Brodmann's 42. And what happens is there's a string of meaningful sounds that enters into the Warnick's area. And we went over the anatomy in part 1. Okay, so if you'd like to go back and look at the areas, that would be helpful. Okay, now the sensory motor intelligence, we have it when there's print perception, or the ability to see letters and know that these are letters and I recognize them, and these are letters can be put together to form words. Otherwise, we call it print sensitivity. Now, the child or infant is born with the ability to see shapes and houses and abstract pictures and really figures. And once they are exposed to print around the age of 6½, this fusiform gyrus, and I mentioned in the first section, the fusiform gyrus is located in this area. And then it says that it recruits substrates of the occipital region. The occipital lobe is located here, and the occipital lobe is for sight. It's related to the ability to see. Okay, so the fusiform actually recruits and take from the occipital lobe, and this actually forms what we call the visual word form system, or the visual word form area. And this area becomes modified. So the child is born with this ability, and now we have it where the child is able to hear, see, and know letters and words, and adding on to what he already knew how to do. And this is called cortical competition, okay? Competing. Learning to read actually competes with the existing material, or I will call it nuclear material, that the child is born with. Here's another view of the visual word form area. This is critical for reading, and children with dyslexia tend to have a problem in this area. Okay, now the modified area is print sensitive, and it processes grapheme and phoneme. There are many areas that will process grapheme and phonemes, but this is one of them that do so. Reading occur in this fusiform gyrus in the area of the visual word form area, and writing and learning how to spell is all occurs in this area, the lower part of the temporal lobe. Okay, so we need to know that there's also an extensive system, writing system, and also reading system that's associated with the visual word form area in the occipital lobe. Okay, now we mentioned earlier that we have critical competition between the inherited areas and also literacy, the learning how to read. And the more the child comes into contact with reading material, the more modified the area becomes. Okay, so let's go back to Piaget's concept of sensory motor. So we have the visual sensory motor information, and what happens is the child becomes print sensitive, or the ability to see print, and then there's a development of the visual word form area. The same thing occurs in the auditory sensory motor area. So what happens is the child, and this happens early on, the child's able to recognize his mother's voice. Okay, so this competition and this formation of the auditory word form area occurs as in the infancy, when the child's in infancy, where the visual occurs when the child is around the age of 6 years old. So the child is able to discriminate words, okay? And these are words and sounds of the culture and those that he or she have been exposed to. And then, again, we have the auditory word form area. Now, it seems as if there's not a lot going on here, but it's quite a bit. If we look at a map, a mind map of this, these activities, we can see that literacy leads through the environmental experiences. Literacy occurs. The level of literacy happens through contact with material. Okay, so when we look at this, we have connectivity links to grapheme and phonemes. Now, in the previous presentation, I mentioned connectivity. Those are the fibers that connect between areas of the brain, the learning areas of the brain. Okay, we have where it's spelling words, and there's critical or cortical competition between the new material and old, I should say. And then that is called neuroplasticity. We hear a lot about neuroplasticity, but this is an example of neuroplasticity when you have an area that is set in naturally in when the child is born, that's changed over And there are cells that actually goes through meiosis, mitosis, and continually grows, and it's more so mitosis. Okay, and then you have your auditory center. There's activation. Now, I didn't mention that when the fusiform comes in contact with print, it activates the occipital material, and we call them substrates. Okay, so neuroplasticity occurs, and then we have the anterior superior temporal gyrus is involved, and there's much more that we need to look at when we think of the child learning how to perceive literacy and perceive language, and using both of those sensory areas. Okay, so this area of the presentation is quick, and we're going to move on to the third section in a couple of minutes. Okay, so thank you for listening to this part of it, but we'll see you in a few minutes to see part 3 of this presentation.